Welcome to Cpp.chat, an optional reference to what's going on in the world of C++, chatting with guests from the community. But before we get embedded into this week's episode, John has a disclaimer to read.
Thank you, Phil. The academic degree plans presented here serve as a guideline. Key milestones, prerequisites highlight significant achievements that must be completed in the degree track. Students who do not follow the plan and/or who do not complete identified milestones may jeopardize their financial aid, if applicable, and/or delay graduation. Cpp.chat recognizes the important connection between student success and academic preparedness. Students may be required to complete courses before enrolling in the sequence of courses. Summer and/or intersession courses may be required to graduate within a specific number of semesters. Departmental developmental course credits earned do not count toward degree completion requirements. So our guest today is JeanHeyd Meneide, and he's better known as ThePhD. Welcome, JeanHeyd. How are you?
I'm doing great. How about you, John?
I'm great. I looked for an academic disclaimer specifically for you, and was delighted to find that one. Yeah. So, Phil, we have some news things we want to talk about before we get into interviewing JeanHeyd.
Yeah, a couple of things. We talked a few months ago, actually, when it first came out, about Titus Winters's paper on ABI, Now or Never. In fact, it did the rounds on social media as well. He's now written a follow-up paper which goes into a bit more detail, and I know a big chunk of next Monday in the Prague ISO meeting is going to be set aside to discussing those papers to make sure we will understand what's at stake and whether we can do anything about it. To be honest, I think most people are not too hopeful, but you never know. So the subject of what ABI means in a C++ context, because it's not just one thing, it is really interesting to dig into, and what all the challenges are in whether we maintain it, whether we break it, what the consequences of that are. So if you didn't quite get it with his first paper, maybe the second one will get through to you. I'll put the paper numbers in the links in the show notes, but it's P2028 is the new one. That's an R0, and the first one was P1863, and that's R1. So yeah.
So I noticed Sean Parent had tweeted something about ABI compatibility, which I thought was interesting, and I didn't quite understand what he was saying, but when Sean says it, it's worth listening to. If we are going to decide, and that's what Titus is actually asking for. What's our policy? What are we trying to do here? And one of the things that Sean was pointing out is that part of what you need to do is just document to developers and say, these are the things you can rely on and these are the things you can't. And the standard more or less tries to do that, but it doesn't really give you a strategy. In other words, the standard would say, well, here's this, but doesn't say, but you should never do this, or you should never do this, or you can expect that we will change in this direction, and things like that. And those are the kinds of things that should probably be documented as well. And we just kind of have this expectation, and we should think through these things. I mean, that's what Titus is trying to raise, I think, is awareness that we need to think through these things. We don't want to be in a situation, which is what we are in, where we've kind of boxed ourselves in by simply saying, this is where we are, and what's the incremental move forward, rather than saying, what's the long-term strategy for how you can do this. And I think the point he's making is very much the case, that we have told ourselves that C++ is about performance. There's no faster language. There's no room for a faster language than C++, and this is the way we do things. And then we end up with situations where we say, well, yeah, for legacy reasons, this isn't as performant as we'd like it to be, and we just live with that. Well, we got to make a decision, which is it? And,
Yeah, I think the case that Titus is making here is pretty compelling, right? When I got into C++, it was very much about always being about getting the most performance out of stuff. That was like the reason I wanted to do C++. So when I first kind of hit this strange new world where people were kind of relying on the fact that they could take binaries from like 1998 and still compile them and like run them with like 2015 stuff, that like blew my mind. When did this happen? but it's apparently a very common practice, especially like among distribution maintainers for Linux distributions, et cetera, right? Their whole ecosystems, their packages, right? They don't really, even though there's a huge emphasis on open source and being able to compile from source, a lot of those distributions are powered by binary files, right? So if those two can't talk to each other, you end up in a very bad situation on your distributions and everything else. And so, I sort of understand where they're coming from, but on the same note, because we've kind of not talked about it at all, or not really formally gave like this is what we will do about API or what we won't do about API, we've just had this like lingering thing where we just kind of support APIs for like 10, 15, 20, even in one case like 25 years of just having the same exact API and just supporting it all that time. And that's, there's value in having something that's stable and that can last a long time, but there is still also value in being able to make changes, especially when C++ as a language has come so far and we've learned so much. There's so many things that we want to fix, but we can't for either legacy reasons or, as is the case with a lot of things that some proposals I brought up and proposals that Titus is overseeing, can't be done for API reasons. And that's like, we have to take performance hits there when, again, the general rule is, this is the fast language. You can't get faster, right? If you optimize some C++, you have the fastest possible implementation, like portable implementation you can get to. Sans if you like wrote the whole thing in assembly by hand, right? Like those are your two levels. Right. And so to have this idea that we're giving up performance for the stability kind of thing, it makes sense from the perspective of like a long-term vision, but like to keep supporting something for so long and still never actually say what exactly our stance as a committee is kind of bad,
Mm-hmm. Well, and I think it has an implication for what we accept as a library. In other words, if you're going to say, well, no, we can never change the ABI, you have to be, I think you should be much more conservative about what you're going to do in the library, because, and one of the things that Bryce has talked about is, we don't want to standardize things that we're still researching. And I'm not sure that we'll ever stop that, right? I mean, I think we thought we understood, or the committee thought they understood hash tables back when they standardized the unordered, containers. But we now think, well, that wasn't a good way to go. We know better now. But my question is, will we know better 10 years from now or 20 years from now, where we'll say, oh gosh, those guys way back in 2020 didn't know what the heck they were doing. And if that's the case, then maybe we really need to rethink a lot of things. I think a lot of people are I am feeling more that we need to look more at third-party libraries and keep them as third-party libraries and not expect that the standard is going to have every tool you need. And we need to think more about, well, obviously the solution everybody's talking about is let's figure out a package management solution so that we can use third-party libraries less painfully than we have to now.
Yeah, I definitely agree with that. I remember at one point, right, I stopped doing a little bit of C++, right, and I started going to some other languages like Haskell and everything else. And I've heard people complain about like, package management for Haskell is a pain and whatever else, right? But I remember like, because I was coming from C++, right? So I was like, okay, right? I had an idea of what pain was, right? So I walk in.
There's the show title.
Yeah, I walk into like this Haskell ecosystem, like expecting like, all right, I'm gonna have to do some like CMake S, or I'm gonna deal with some like automake, like crazy heck on earth kind of deal, and. No, I run one command and it sets up a project for me. It pulls in dependencies that I need, like just like specified in this very simple file. And in one command, I was done. And I just sat there and I was like, so where's the pain, right? Like, where's the nightmare here, right? But like, no, I had Stack, I had a couple other tools, and it just worked, right? And usually you think, right, for a lot of programming language, they're usually like Unix first, right? And when you go to Windows, like the support just drops off a cliff and everything's terrible. But no, I was on Windows. I pulled some typical Haskell tools that even the people on Linux distributions were talking about. I used it and it just worked, right? And there's no pain involved or anything like that. And so, right, comparing that to like the state of the art of C++ is like, Ooh, we've got work to do. We definitely have work to do, right?
Yeah. So, do we have other announcements? Do we want to talk about Prague, which is just around the corner?
It is, yeah, just next week. In fact, I'm going to be flying out there on Sunday.
You're going to be there? Are you going to be there, JeanHeyd?
Yes, I am going to be there. Got a couple of proposals I need to kind of make sure get through. Prague is last minute for fixes, and anything else that were national body comments and all stuff get final resolutions and all that. We clean up everything, then we ship the final, basically the final specification that's going to be approved. They're going to be stamped by the ISO and say this is now an international standard, CS+20.
So I haven't actually been at a last meeting like this. Aren't there weird rules that we can't start talking about post 20 officially? But I assume we don't just stand around saying, "Gosh, I wish we could talk about the next standard." What is the guideline there?
Yeah, so we can't approve. We can't approve through a motion. Like a paper to be put into the C+23 draft, right? Because it doesn't exist yet, right?
You can do work, because the vast majority of what the committee does is give responses to writers and say, come back with this, address this, take a look at this.
Yeah, exactly.
That's most of what they do anyway. So actually putting something in the standard, that's the easy part.
Yeah. So it actually, for the most part, it is the easy part. Yeah. But sometimes you can get some hairy situations in in the final, at the end of every meeting there's a formal plenary where they do the rubber stamping of things. But sometimes things don't get rubber stamped, and some people raise their hand and say I have an objection, and then it goes to a formal vote and comes down to national bodies and voting on stuff and everything else. But yeah, for the most part, we're allowed to basically talk about anything, but the only things we can finally formally approve are CS+20 things. Though, as a bit of a side note, in the last meeting, which was Belfast 2019, I actually got the first feature for C+23 pseudo approved. So they voted on it and they said yes, but they'll have to redo the vote again, I think, in next meeting, which is in Varna, Bulgaria. Yeah. Sure. But I got the feature rubber stamped approved, and that was the first CS+23 feature that got through. So that was pretty cool.
Pre-approved.
Yeah, so pre-approved, right? So not fully approved, but
we're engaged to be approved.
Yeah,
Did they give you a ring?
Yeah, get a ring and everything for CS+23. But yeah, so that was kind of nice. But yeah, for the most part, most things, we gotta wait, gotta do the process, and we have to wait, and the ISO, et cetera, et cetera. So that's just how that works.
Yeah, priority would definitely be given to the finalizing C++20 national body comments and things, but there will be times in between those where, of course, we'll talk about what's coming next. In fact, I won't mention a name because I know we can be a bit funny about repeating what's been said in emails and things, but somebody who definitely knows what they're talking about said that this is a bit like filling an oil tanker. If you're pumping oil into an oil tanker, it can take a long time between turning that tap on and the oil coming through, and also turning it off and the oil stopping. So nobody is going to, when you're finished, just turn the tap off and then just wait for that oil to finish running before you start the next one. You keep it running, even though you might be changing things over. So in the same way, we are going to carry on talking about C++ 23, 26, whatever. As JeanHeyd says, we're not going to be approving anything for it, but we've been talking about 23 for a while, so that's fine.
All right. Excuse me. So yeah, that's just around the corner. All right. What else is going on? C++ Now update. We just opened registration for conference registration, and also the hotel is now taking reservations. So very excited about this. We have a great program coming. We're just in the middle of reviewing it, so we've got a lot of work to do on the review side, but a lot of great submissions. So I'm very excited.
In case you were there last year and are worried about the hotel situation, I hear from a reliable source that the the whole resort has been booked out this time. Is that right?
That's right. That's right. Last year we had another event, not a huge event, but another event that was happening in the hotel, and they grabbed some rooms from us. But this year we have the entire hotel. And I think we may also negotiate with the Limelight to have an agreement with them as well. But I think most people prefer to be in the closer venue, and the resort is beautiful. So they are taking reservations for that. And as I said, we're taking registrations. Registration is a little different this year. It's not through Eventbrite, but that's just a detail. Anyway, very excited about it.
Yeah, that sounds amazing. Yeah.
So if you've not been before, I recommend you give it a try.
Absolutely. C++ Now is it was my first C++ conference, and I went as a student volunteer.
Yes.
I think this is the last year that I can go as like an actual student volunteer. Yeah, if
we're on the verge of a PhD, is that what we're?
Not quite a PhD, but I'm definitely climbing the academic ladder, which is good. But actually, I guess a quick shout out. Like if you're a student and you're listening to this, you're watching this, please do apply. It's a really great program. They will help you get there if you need assistance, and you can meet a lot of people who are very invested in C++ in the community. We had a lot of great applicants last time too, and it was. I met a lot of great people. People I still keep in contact with, people I still talk to, and you should definitely apply if you're a student and you want to get there.
The message that I've gotten from students is, and I tell people this, and it sounds very self-serving when I say this, but it's career changing. It literally is career changing. The experience, the people you meet, the possibilities that it opens up for you, you really don't want to miss out on this. Having said all that, the deadline to apply as a volunteer is tomorrow, and unless Phil performs a miracle by the time you hear this, it will be too late. But next year, never too late to start planning for next year. Too early to start planning for next year.
You don't even have to wait till next year, because for C++ on C, another great conference, the student program at least is still open. Volunteers is finished, unfortunately. We've got a full set of volunteers now, but the volunteer program, the students program is still running. So details on the website for that. As I say this now, and this should almost certainly have changed by the time you hear this, there's only one early bird ticket left. So we'll be moving to full price, and hopefully, if not by the time this gets released shortly afterwards, we should also be releasing the full schedule, or at least the list of speakers. So it's not out yet, but it will be soon.
Okay, and I will, just to finish this up, we were talking about C++ Now and C++ on C. If you're a student and you have an opportunity to go to a C++ conference, you may be intimidated because there's all these people who know so much more than you do. And you read the list of talks and you're not even sure you understand what the talk is about. Don't be intimidated. If you have any understanding of C++ at all, you will get a lot out of any of the C++ conferences. Even C++ Now, which is one of the most expert of the conferences, it is still very welcoming to people who are still kind of early in the learning curve.
For C++ on C, we have managed to get quite a lot of accessible content in this year. So I don't want to say beginners content, because it's not necessarily just for beginners, but content that anyone could appreciate, including beginners. So quite pleased about how that's worked out.
That's great for the community. That is so wonderful. All right. What else do we want to talk about?
Just to round out conferences, won't spend too long on it, but there's still a few call for papers open. We mentioned Core C++ and CPPP last time. They're still running. I think one of them finishes in a week or so. But we didn't mention before that the Italian C++ conference, their call for speakers is open. And that's I think that's in May or June as well. I did make a note of when the call for speakers finishes, but that's the conference roundup. And one final piece of news before we get into the meat of the interview today. Another piece of JetBrains news, but this one should be of interest to people who don't use JetBrains tools as well. It's the developer ecosystem survey. We talked last time about the Meeting C++ survey. Well, now it's the JetBrains one. It's another one of the important community surveys, so do encourage people to fill that out. That should be open till at least the end of February. So I'll put the link to that in the show notes as well. Some people have said it's quite long. I don't know if that put you off. It is a bit long, but it's also quite fun. So there's a few little Easter eggs in there as well. So
Oh, cool.
I'll leave you to find out what they are.
I haven't done it yet. I have done Jens's. Did we mention Jens's?
We mentioned that last
show?
time.
Yeah.
So I believe that's still running as well, isn't it?
My understanding is he plans to just kind of leave it running.
Right.
Once, I asked him about this, and I said, well, we should then once a year encourage everybody to take it again, even though but basically he wants to just leave it up all the time. And then we'll encourage people to take it again every year, kind of, because some of the questions he asks will be different. Right. Because your job changes, or your role changes, or the tools you use change. Some of those answers will be different. So that's kind of cool.
Okay.
All righty.
So I've been asking you for this week.
Yeah. So let's start talking to JeanHeyd about what you've got that you want to talk about, including embedding Circle. What is the deal?
Oh boy. So originally I kind of left stood in bed and all that stuff kind of just in a pile somewhere. And I was like, I'll get to this eventually.
Is it worth briefly mentioning what stood in bed is?
So the thing so embed and stood embed and hash embed and things I'm going to be talking about. So it's basically if you've ever been working in C++ and you say, oh, I want to get this file, into my program, right? Usually the typical way to do that is just like IO streams at runtime, et cetera, But when you have something like hash include, you're thinking, oh, well, I can do that in some way with like a file, right? I can like include like a text file or something, just have it embedded in my program, right? But you can't really do that in C++, right? You can't just take any old file and just splat it into your program and say, listen, I want these bytes just here, and I want to be able to like make an array and do stuff with them.
So for example, if you had an image, like whatever, your splash screen or something like that, you can't have that in the program as an image. You could write it as an array of bytes or something like that. Bizarre literal like that. But if you actually have a PNG file and you'd say, I want this file so that I can splash it on the screen, you're going to have to read it from disk in the way C++ works right now.
Yes, exactly. And so, there was a lot of different ways that people got around this, right? Some people made crazy runtime systems. Other people, hacked up their build system. There's the typical, make file with the xxd command on Linux distributions that people use to basically splat out a big fat array of, bytes, and then they load that into their program. That's what they do. And so what I thought was that, well, this is kind of a request that people have had since the comp. I've actually found questions that people ask about this kind of thing since comp.lang.c, right? Like 40 years ago, way back, right? And even Guy Davidson, the proposal officer for 2D graphics, works at, I believe, Wargaming and a bunch of other places. And he does a lot of work with the standards committee and standard proposals and helps a lot of people. He even told me, like, I've been trying to put binaries in my games and other things for 40 years, right? And so this is in my head, right? When I first started this journey, I was like, easy problem, right? We'll just throw it into C++, right? We'll get a single directive, easy peasy, right? Like we've already rejected every other potential form of this, right? Like, so let's do the last obvious thing, right? Just have a standard function that works at compile time that just magically pulls these bytes into your program, and you can get to work with them, and it's constants per capable, et cetera, et cetera. And so that's what stood embed is. It was my very first proposal to the C++ committee, and I've been working on it for a while. And what happened is that during the Belfast meeting, the meeting that just passed in November 2019, I actually finished the real implementation of it, right? So I had it on, I had an implementation on Godbolt that you could actually like go and use. I got an implementation of both GCC and Clang. I was like, okay, I've done it, right? I've proven that this is implementable and that it can do all these things, right? So I picked it up and I showed it to some of the evolution and other working group members for the committee, and they said, all right, we're gonna talk about it. All right, so they scheduled to talk about it. And so I went through all the details, right? And, they pointed out things that are wrong with it, things that I should fix, things that need more specification. And the initial, from the first room I went to, the evolution working group, I got positive feedback. They're like, this is good. You have strong direction to go forward with both the std embed and the preprocessor version, the hash embed, which I didn't think was going to survive at all, but the preprocessor version actually survived. And that was pretty cool. And then I went to the next room, right? The compile time programming room, SG7. What they handle is reflection and compile time programming, right? And this kind of falls into that, right? Because you start getting to the question of, well, if I can get a file at compile time, right, I could pull in a JSON file at compile time and parse it, right? Do what Jason Turner and Ben Dean did in their, their joint presentations at C++ Now and Cpp.Con about context for all the things, right? Where they made an actual like compile time JSON parser. So that like those use cases and those kind of things came up. And so that's why it was shipped to SG7. And so I was in, the reflection room, and we start discussing it. And while we're discussing it, this new language that I had heard of, but I never really looked at, called Circle, gets mentioned. And it just the enthusiasm for Circle just kind of like takes over the room, right? Because and rightly so, because Circle is very impressive, right? So the basic premise of Circle is that everything you can do at C++ at runtime, you can do at compile time, right? So you can open an F stream at compile time and just run that code and load it into a std vector or whatever else and just use it. It just works, right? You can printf at runtime. You can use std.cout at compile time, right? And so everything that you can do at compile time, you can do at runtime. You just include the header and everything's the same.
So we had Sean on a few episodes ago. So
yes,
regular viewers have seen this already, but people who are taking this out of order, go look for Sean Baxter's talk because we spent the whole time talking about Circle. So go ahead.
Yeah. And so the really compelling thing about Circle is that it offered what ConsXpr right now doesn't offer, which is a tangible, reliable execution model, right? So when you program into runtime at C++, right, you have a reliable execution model that tells you this is the sequence of things that will happen, right? Obviously it's covered in the as-if rule. The compiler can optimize whatever else, but like this is the behavior of your program, and this is the way things will be executed, right?
And if you're going to write portable code, that's absolutely necessary, particularly if you're going to have tools from multiple different vendors working together or working in parallel. All that is absolutely required. You can't take these things for granted. As soon as something gets vague, that's where we run into problems.
Yeah, exactly. But ConsXpr kind of lives in a vague world where the compiler isn't necessarily required to only, like, say, compute the results of that function once, right? And so I actually found this surprising when I first implemented, like, the compiler built-ins that actually do, like, what hash embed and std embed do. I actually found that it would call my built-in once, then it would jump out, and it would call it again, and then jump out of my built-in, and then it would call it again, and that finally by the third call, it had figured everything out, and then now finally I could continue with processing and actually do the embedding. And so what you find out is that ConsXpr does not have a real physical execution model that you can, like, observe and, like, order behavior properly, etc. Right? They have loose, like, this happens before that behavior, but you can't, like, write a full program in ConsXpr and have, like, everything work out. Everything was only executed once in this order, right? And so this just becomes a problem, right? Because if you wanted to do what Circle does, like std.cout or printf at compile time, well, you can't run that function 3 times and be like, well, I actually happened to print this, like, 5 times to your command line, right? When you only have one printf there, right? That doesn't make any sense. And so that's, like, the context in which Circle came up in the committee, and it kind of exploded from there. And that, like, we want a deterministic execution model, right? We don't want to overly work on anything. We don't want to do one-off features to solve things. We want a general execution model. We want to, have F streams at compile time or some kind of compile time stream that we can use, right? We want it to look like regular C++. And so I got that feedback while I was there, right? That they don't want, something specific like std embed or hash embed. They want something that's a little bit more like Circle. So after the meeting's over, I was like, well, I've got homework to do, right? So I contact, Sean Baxter. I read Circle. I start putting it together example. I start working with it, and I run into some of the same issues, right? If you have a very large file, right, and you try to parse that at compile time with Circle, right, things get kind of slow, right? And if you use it's slightly undocumented @array keyword or whatever, trying to, like, serialize that into something that can be used like an array that can be like stored in your program to be passed into runtime. It got slow. It got slow very quickly. all the techniques, right? So I kind of reached out to Sean Baxter and I was like, this is kind of slow and I don't know what I'm doing. So maybe as the author of the compiler, maybe you have some tips and tricks for me. So first he pointed me at array, because he was like trying to figure out what I was doing. But once he figured out what I was doing, he just immediately responded, like not even like 2 hours later. He just sends me a tweet. He's like, I'll implement @embed in the compiler. And at that point, right, like that just like my mind just exploded, because I had spent all this time like trying to like doing optimizations, trying to figure out like the best way to do embed, and then I get told I need to go back and figure out a general stream mechanism. So I do the general stream mechanism, and then I go to the compiler author with my general stream mechanism, and he's just like, yeah, no, we're just gonna have an @embed keyword. And it's like, I spent all this time. It hurt. It hurt a lot. So
I don't mean to be laughing at your pain.
No.
It's funny as heck.
It is funny. It was absolutely hilarious, right? And that's why I wrote that first article going full circle on embed, right? So like I start out
no pun intended.
No puns is sort of intended at that point.
Okay. It's kind of embedded in the technology there.
It's a circle within a circle.
Yes. So I did all this work. We ended up coming back all the way around where the author was like, yeah, hash embed is like low hanging fruit. It's faster than all the other methods, right? And it's just better, right? And so he implemented it, right? I benchmark it. Of course, it's faster than literally everything else, right? I have the benchmarks in my in the PhD/embed on GitHub. I have benchmarks of XXD, like if you generate a giant array and use that. I have benchmarks of std embed. I have benchmarks of hash embed, and also I also like.
You're talking about build time benchmarks, not runtime benchmarks.
Yeah, so build time benchmarks, right? So how much does it cost? How much does it cost you in terms of compiler memory and compiler time to actually like construct something? And I gave everything like it's at the best possible light. So I didn't tax the creation of the file, right? So XXD was ran on its own thing, finished, and then I would benchmark actually putting in C++. So that was like the only thing I was timing. And the numbers are for XSD and everything are just atrocious, right? If you start out at like 4 bytes, 400 bytes, like everything's fine. You get the 4 KB, things start falling off. You get the 40 KB, things really start falling off. You get the 400 KB, like GCC freaks out, Clang starts consuming a whole lot of memory. MSVC just completely loses it. You get up to 40 MB, like MSVC is now in consuming gigabytes of memory, right? Like Clang is crying somewhere. GCC is already hitting the swap and it's like, it's like trying to figure out how to do it. It was bad. And the compile times are just exponential, right? And so what I found out was that these are real pains, right? It doesn't when you create a gigantic array of a bunch of literals, right? It doesn't scale, right? If you have to create an AST node where each of those things is another AST node, right? That's all very expensive, right? And even in the case where you attempt to optimize it, you can't actually optimize that well because the way C++ parses, right? So, and this is part of our C heritage, right? But the preprocessor requires a very specific tokenization of your text file, of your source files, right? So every single number you put in that gigantic array is its own token. It has to be parsed as such, right? Because it needs to be handled by the preprocessor for macro replacement or line directors or whatever else. And so that alone accounted for so much memory bloat that it made it impossible to do anything, right? I think even Crunch and Jabot wrote another blog post not about embed in particular, but he went into Clang and he attempted to optimize this array, this large arrays, right? And he only got minor gains that were like anywhere from 10 to 20%, whereas std embed and hash embed were orders of magnitude memory savings, right? We're talking about when GCC was consuming 8 gigabytes to handle this array, the version with hash embed or std embed was consuming 40 megabytes, right? It was that kind of difference in memory usage and everything else. And that's kind of and so it was all for all these reasons, right? We know it's a big problem. We know embedding large arrays is a big problem in C++, right? It slows down your compile times, right? I even tested this with a bunch of developers reached out to me from FPGA developers. So they develop a lot of hardware-based stuff. They write a lot of C and C++. They have lots of large data arrays, right? Because they're they write out their firmware memory and they dump it onto the chip and everything else. And I gave them a test of hash embed and a bunch of other tools, and I was able to improve their build times by over 50% just by handing them like hash embed, right? And at the time, the hash embed I gave them wasn't even the optimized version. Like that was like the dumbest possible information I could do, and it was still flat out better than almost everything else, than any other way of doing it. And so it was for all these reasons, right, that I was like, how do we not understand that, like, yes, there's a general, like, we can open an F-stream at compile time and do all this work, but is that really like the thing we should be doing, right? Like, if we wanted to have it so that this was something that was usable for even just 40 megabytes of data, which people think is too large, but is actually a very common data payload that like firmware developers and other people use. The fact that the compiler just spirals out of control at that point is just not good, right? And that's why we need like a dedicated thing for it. There's also something I learned while I was actually not at the C++ meeting.
But I would argue this.
Yeah,
I'm not saying you're wrong on that, but I think that the reflection committee needs to think about that feature in the context of, do we want to go down a circle-like path, and how do we make sure it makes sense together? So I do understand your frustration. You probably were right. We need something dedicated for this. But I also appreciate that the committee isn't just saying, oh, that's a good idea, let's do that, and then we'll look at something else later. You know, let's look at the whole thing together and say, you know, I mean, they were right. We want some kind of general, reliable, you know, compile time world. And it may be that this special case, which is going to be common and problematic at scale, maybe it needs its own feature.
Right, and that was part of it, right? But one of my pushbacks on that was like, if we do go down this road where we change the direction of reflection, right? Because we've done this twice before, right? Before it was very much template-based reflection, where you know it looks like type traits, and we're like, no, it should be const_spr based, like, you know, looks like regular C++, but it's all const_spr. And we're like, no, we need to go a little bit further than that. And so maybe circle is kind of like the right model or the right look for this kind of thing. And at that point, right, you're taking a useful feature that could be in people's hands right now, that's implementable right now, and pushing it like further and further off into the distance. And so my ultimate point, I think, was that at some point we would come back around to the fact that this didn't scale, and we'd be back talking about something like Stood Embed just 6-9 years later, after we kind of reevaluated, you know, the reflection direction, right? And so while I understand that we want to have a like cohesive, like good, like reflection, general purpose reflection mechanism right now, because there's a ton of use cases, right? I mean, you just ask anybody, they already have like serialization, like, and just all sorts of ways of things they want to do with reflection. There's still some merit in like things that are deliverable like today, right? And so that's kind of the balance that I wanted to strike, and that I wanted us to move into going forward. And I think that in reading the article and seeing that Circle kind of had to go back around and make the same decision itself, for performance reasons, like sort of solidifies that whatever direction we do end up picking, we will eventually need something like this. So maybe it's better to start now than later, right? And that's a conversation that has to happen in the committee. That I actually didn't think the paper would be scheduled to talk about, because it's like a CS+23 thing, but apparently it's going to be scheduled to talk about in Prague, and so that's another reason why I have to show up and talk about that. The other interesting part about Stood Embed and Hash Embed is dependency management, and so this is actually one of the more serious points of contention in the main room and evolution working group. With C++ today, right, ignoring the build system, right? You know, how do you do that? But ignoring the build system, you can know every single file that goes in and out of, you know, your translation unit today, right? Because everything has to be hash included, and then, you know, whatever comes out is just, you know, your object file, right? Whatever the compiler says comes out of it. And in that way, you have a total graph of all the dependencies, right? You may have to generate some things with the build system, right? You have to, you know, make a special make rule for XXD, or, you know, UCMake to generate some binary or write some files or whatever else. But by the time you kick off the C++ compiler, you know everything that's going in and you know everything that's coming out. Stood Embed changes that. While the preprocessor version hash embed works exactly like hash include, and so that you can know all the dependencies ahead of time just by doing a quick like up to stage 4 scanning or stage 5 scanning of like stages 1 through, so that the compiler has 7 phases, and so you do all the pre-processing phases, right? So it's phases 1 through 4, right? 1 through 4, 1 through 5, and that gets you like all the macro information, all dependencies, right? Fully expanded translation unit.
Because the hash embed has the file name.
Yes.
So all I have to do, I don't actually have to understand the language at all. I just have to understand the preprocessor. Hash include means I'm dependent on this file, and I have to look in it to see what it hash includes. And then hash embed says I'm depending on this file, but all I'm doing is pulling the file in. So there's no
recursive anything.
That's always a leaf node, right?
Yeah.
So I don't have know anything about C++ in order to figure out what my dependency graph is.
Exactly. Yeah. And that's a benefit, right? To a lot of tool developers, like that's how that's a great part of the process, right? And so std embed muddied those waters because what std embed is it's a constant evaluated function, right? So it's a regular C++ function. So you could compute a string view from a bunch of different sources at compile time and then present that to std embed. And that makes it impossible to actually know definitively that this is the thing that you want. And so it became impossible to kind of determine all of your dependencies completely at like preprocessor time.
Right.
And that became like a sticking point. And so what I've done is in the latest revision, and you can check it out on Godbolt and other places, but I created a hash depends kind of thing. And so what you can pass into it is either a single file name or a directory path with a star in it that says depend on these things, like everything in this directory, or something with a directory name and then a star. And what that means is depend on everything recursively in this entire directory. And so that alleviates the pain of std embed in that you can still, a scanner can still run through your program and by using the same dependency information, know everything that you're going to include.
Well, unless you do something like create a new file.
well, we don't have file creation at compile time yet, but I'm not. That's not
with Circle, you could do that.
Well, yeah, with Circle you could do that, right? And that's part of like the ramifications of having a real file system I/O at compile time. And there's also other ramifications as far as like, the view as compared to the view of the file as compared to the host system versus like how it's supposed to be in the target environment and like how bytes are interpreted, and et cetera. It's an interesting rabbit hole. But basically, I solved the dependency problem for std embed by creating this hash depends kind of thing. And I think that for the most part, that covers the like 99% of the concerns. I think there's still some people that want to make it so that if you try to std embed a file that doesn't come from hash depend, right, that isn't listed in somewhere in hash depends dependencies, that you get a hard error. Right now, the way I've implemented is that it's a soft like warning kind of thing. It's like, oh, you included something, and that's not included in your dependency information. Are you sure about this? But I think a lot of people want like a hard error, right? Like you try to include something that is not going to be included in your dependency list. Like
that's not for the committee to decide. The committee can say you have to do a diagnostic, but I mean, I guess the committee could say it's an ill-formed program. But the compiler can still go ahead and form it. I mean,
Yeah, and so it's that kind of thing. But the people on the committee very much want to give like hash depends and std embed like normative teeth. Like if you don't do that, then your program is ill-formed, right? Or like it doesn't properly work out.
So you're saying it depends?
It depends. Yeah. And so that's kind of where std embed is and hash embed are right now. So I think it's actually viable to make it early into C++23. I just have to figure out that. I mean, I have to address any other concerns, right? Because there are people who have like security concerns and other things like that. But I dug really deep into security concerns. I actually contacted a bunch of like professionals, et cetera, like what are the security implications of being able to open this at compile time? And what they said is like nothing. Like this is even less. This is less trouble than a hash include would be as far as like trust and like safety and what that means. So I'm like, okay, that's off the table. Yeah, so that's like the fullness of what's going on with hash embed. So I think right now it's in a very stable place and it's not too bad. But man, I was I was very much disappointed that I went to circle and I had to come back around and we just like, well, I'm just gonna put add embed in the language. It's like, but I went and did all this work.
You're richer for the experience.
Yeah, I built character. That's what that's what my parents and I built character. Yeah.
Speaking of Unicode, oh sorry,
What doesn't kill you makes you stronger.
Yeah, exactly. It's like Saiyans, right? You know, all that stuff from Dragon Ball Z and everything. But yeah, I'm definitely richer for the experience. I know way more about constant evaluation than I ever wanted to, thanks to GC and Clang and the differences thereof and how they handle stuff. Yeah, definitely learned a lot.
Well, I'm definitely rooting for you. Even though I don't have a personal use for it, I know from hearing from different people that it's one of those things that if you need this feature, you really, really want it. And there's quite a lot of people that really, really want it. So yeah, it's going to definitely make the language better if we get it.
Exactly.
So what do we want to talk about? We want to talk about Unicode?
Well, we could talk about Unicode, or we could talk about optional references, or
well,
Unicode is a much less of a minefield and much less ranty than the optional reference.
Well, let's go for the rant. We've only got 12 minutes. So
oh boy, so yeah, speed ranting. Okay,
speed ranting.
Oh God.
Good title.
I actually do think that optional reference is something that's kind of topical. People are talking about this right now. So you want to give us the background on what people are, what's the concern? Can't I have references in my options now? STD option doesn't have, can I have an optional with a reference in it?
So the answer is yes, you can, but no, we won't. And the reason it's like this is the history is actually really long. The paper actually dates back like 2002. Even the original paper that proposed optional to C++ was predated C++11, right? We got it in C++17, but it was like a 2002 paper.
Sure.
And originally the paper had references, it had reference support, it had regular it was the full optional that you'd expect from like boost optional or TL optional, right? And so it went through the committee. The first roadblocker was that like comparison operations, like how do we do comparisons, right? So like what happens when one's no op and one's not no op? What happens when both are the same, right? Like how do you do those comparisons, right? Do you even provide those comparisons, right? And so that battle waged on for a while, and then it was solved, right? Where they just said, well, if both things are there, you compare the values, right? Because why wouldn't you, right? If they're no op, then you just return a default, true, false, et cetera, for the equals and not equals and all of those. So that was fine, but then the topic of references came up, and what happened is like early in the paper revision, the paper was handed off to a different author than the original. The original author of the paper was the person who initially proposed and got accepted the boost optional that everybody's been using. He passed off the paper. The paper gets some changes, and where they bring up a little code snippet that shows like if you have an optional of int ref and you have an int x and you assign x into it, right, and then you assign another value into that you make int y of 20, you make int x of 12, and you make int y of 24, right? You have the optional reference of int ref of the first one pointing to x. You assign it from x, and then you assign again with y. Does this make it so that the original x turns into 24, or does it make it so that the optional thing just holds a new pointer kind of thing or new reference to y instead, right? The different value. And this exploded a huge debate in the community, right? And this wasn't the first time the debate had happened, right? This debate actually happened on the Boost mailing list, and it's like 100-something emails. It just goes on and on and on. I read through all of it, unfortunately. But they hash this out on the Boost mailing list, and they come to the conclusion that rebinding, which is where you take the value, which is where if somebody assigns into the optional a second time, like with a different reference. That you just rebind what's inside, right? So you make it point to the y rather than overwrite the x, right? Mm-hmm. Just do that, right? And they brought a bunch of different reasons why that was a good idea, right? It's safer, it's better, it's more regular, the list of reasons went on. So Boost figures it out, Boost proposed it, and then it gets taken off the table. And the reason it gets taken off the table is because people didn't say, no, the rebinding thing that you're doing is controversial, right? Because this other method of assigning into the x, right? So you have the optional, right? You say equals y. Well, that should assign into the x. It shouldn't just rebind the optional.
Okay, so let's make this clear.
Yeah.
In Boost optional right now, if
yes.
I have an optional that's an int ref,
yes,
and I assign y to that, I am not changing the value. Well, the first time I do it, now the optional contains a reference to Y.
Yes.
But then if I assign X to that, I am not assigning the value of X into Y. What I'm doing is I'm assigning the reference to X into the optional.
Yes, and so the optional will just point to a new. Will just point to X now, right? So it won't override any data or anything like that.
But if I were to read from it, it's going to dereference the reference.
Yeah, it dereferences the reference, so it'll point at X, right? Right.
So you can understand why this is, controversial. I mean, this is crazy. This is crazy.
Right.
And C++ doesn't even support rebinding in general. But with the optional library, rebinding is what boost optional does.
Yes.
And so for the first exception of the standard, that just wasn't supported at all.
Yes.
Is that right?
And so so what the standard did is they said no references in optional, just period. Just like take it out, like we don't want it in there. This had interesting consequences because that same idea also showed up in variant and also showed up in the upcoming proposal for expected, right? So expected and a lot of like stood expected or TL expected, or even the proposals expected, right? All kind of wanted to support references because this is supposed to be a thing for return types, right? And how many functions return references? A lot of them, right? So they had
you get outside of assignments. I think it's kind of a dubious idea. Returning references is a little scary.
Yeah, it is a bit scary, but it happens a lot with like caches and other things like that. But the idea is that we kind of just nuked it out of all of those, right? So it doesn't exist in variant, doesn't exist in expected, et cetera, right? And again, it was from the same idea, right? That you can't pick between doing the rebind or doing the assign through, right? They're both equal semantics, and of course there are other people who are like, well, just use pointers if you want to rebind the optional, right? There are a bunch of different opinions in the room. When I walked into this scene, right, it was in like 2018. It was after my very first committee meeting at Rapperswil, and I had the idea that the two were equal, right? That rebind and assign through were like equal like things, right? But just to be sure, I ran a survey. I put out a survey to the community and I said, like, how do you like your optional reference? How do you use it? What do you use? Like, do you not use it at all? Do you have any special support for anything? Like, do you have like void returning support, whatever, like et cetera, et cetera. So I did that survey and I got back the results. And what really perplexed me about this survey is that nobody had implemented an assign through optional ever, right? And that confused me because when I went to the committee, when I talked about this on the committee, when I presented the paper for a simple slimmed down optional that didn't choose rebind or assign through, but just was like put a reference in optional so that we can like move the ecosystem forward. People talked about assign through like this was a sure implemented thing that had completely consistent semantics that always worked. And what I found was that nobody on the committee and even the general wider community had actually implemented the thing that in the survey, 50% of people said, I want an assign through optional. None of them implemented it. And that was scary for me, right? Like,
well, how many implementations of optional are there? I mean, there's the boost implementation, but.
Well, so there's actually a ton. So there's Jonathan Mueller's, there's Tarn Lamas or Cy Brand, there's Martin Monet's, there's Isabella Muertos. There's actually a ton of different optional implementations. LLVM has one.
And they all did rebind.
So a lot of them did rebind, but some of them followed exactly what the standard did, right? A lot of them were shims for the standard, and so they actually removed it. And some were actually considering to put references in their optionals, but then they stopped because they saw what the decision that the standard committee makes. So they said, no, we just won't do it. We won't put it in. And so to me, that was really bad because we had an outsized influence on the way people programmed with optionals and the way people handled optionals in general in the community. And we had based our decision on something that had no implementation experience, right? Like at the point that I went to the standards committee with a paper was in 2018. At that point, boost optional and TL optional, a bunch of other options had like 13 years of like industry hardened deployment experience, right? People were using it all over the place. And to see that somebody could advocate for something that had no deployment experience, no implementation experience, didn't see the broad side of boost, was specifically argued down in boost, right, that actually produced like a buggier implementation that generally produced more error-prone code. And to see people argue for that thing and talk about it with like 100% certainty that it was real, but without actually doing any of the homework, like that, like that really destroyed me. Like as far as like going to the committee and like seeing, because I had absolute faith in these people, right? The reason I did the survey, right, and the reason I didn't have absolute faith in rebinding was because I completely respected everybody on the committee and their opinions and what they said, and I just took it as law, right? I was genuinely expecting to find like a wealth of just implementations of an assign through anything, and it didn't exist, and that bothered me.
Well, in general, this bothers me a lot. The committee discounts, and you can take it as boost, but it's really general experience, right? We have libraries in Boost that are, many years old, lots of people using them, as you say, hardened industry experience. And the committee will say, but that wasn't designed right. Let's redo it all. We have this discussion with the ASIO, where a lot of people are on the committee are saying, well, if we were to design that today, we would do a much better job with the API. It's like, yes. And if you do that 6 years from now, you will be in a situation where you don't have any experience with what you've designed, and you want to start over again because now your design is 6 years older than it should be. At some point, you have to value experience and standardize what you've got. And the committee loves to tinker and say, oh, well, we can improve on that by doing, hey, I got an idea. We get this vector thing. Think about memory we could save if we did a specialization for Boolean.
No one would ever do that.
No one would ever do that, except we do it again and again and again because we are smarter than experience. And so now you got me ranting, which is what a surprise, right?
Ranting is optional.
All right, so we're almost out of time. Do you have an endpoint on this? Where are we at on optional right now?
Gosh, so the reason I wrote that blog post, the reason I actually wrote a new paper that kind of summarizes like all of the design experience and implementation experience that's gone to the industry so far, is because a paper popped up from Mr. C++ actually, right? So I saw that paper and I was like, oh no, they're going to walk into the same exact problems that I walked into, right? They're going to walk into a room, people are going to say, assign through is totally like fair and implementable. And it's like, no, this thing has no implementation experience, right? Like, and so the point of my article in my paper was a bit of a call out and also to arm like Mr. C++ and Peter Somlad, who helped them write the paper, with knowledge, right? Like you should know going in that people did not do their homework, right? And that you should be aware of that. And so I took their criticism seriously because I had not done the homework yet. I was new to the committee. Everybody said this thing was true, and it turned out not to be true, right? So I gave them that paper and that article to say, listen, I did the homework. Here's the survey. Here's the research. Whatever decision you come up with, whatever, it's fine. But as long as you have an informed, like honest discussion about like everything that happened, the deployment experience, like what we've learned and et cetera, right? Don't go in there and get blindsided like I did when I first presented my paper about a bunch of things that had no implementation experience, that nobody had ever thought through, and that nobody ever took their logical conclusion, right? Like, don't let people take like a snippet of code, wave it around in your face, and get everybody scared, right? Do your due diligence and stand fast on what you understand and what you know. Yeah.
Phil, I sure hope we can come up with a title for this episode because
No,
because I haven't heard anything yet that would be a good episode.
No. We'll just call it Untitled.
You will just call it Untitled, yeah. All right, so let's try to get that blog post in the show notes, right?
There's 2 blog posts, in fact.
Yeah. Okay.
The full circle one and the binding references.
So our tradition here is to wish everyone safe coding. Although after this talk, people may think safe coding is there's no possibility, but we still are optimistic, and we wish everyone safe coding. So join me, everyone, safe coding.
Safe coding.
Safe coding.